Welcome. In this video, we're going to focus mainly on writing the equations of different kinds of lines. And we have different formats for considering these different lines. One that we should be familiar with at this point would be y equals mx plus b, or slope-intercept. And we call it slope-intercept because it's very easy for us to identify both the slope and the y-intercept. So this might be something like y equals 1/2 x plus 4. Now, standard form, that's the same. That would just be a way of rearranging this. So if I rearranged this, I could say that would be negative 1/2 x plus y equals 4. And if I wanted to get rid of that fraction, I could multiply everything through by negative 2. And then I could say x minus 2y equals negative 8. So what we have here are two equations of lines, and they're actually the same equation, just written in different forms. So the main thing we want to talk about now is point slope form and how that's useful and how that's going to help us. So for our definition of point slope, we say given some point, x sub 1, y sub 1, and a slope, which we'll call m, the equation of the line which passes through that point with the given slope m can be found by the following formula. We will say y minus whatever that y sub 1 value is equals m times the quantity x minus the x sub 1. So this is my point slope formula. And one thing I want you to notice about this point slope formula is it's really similar to a formula you already know. If I look at this x minus x sub 1, and that's times m, if I divided that over to the other side, I'd have y minus y sub 1 over x minus x sub 1 equals m. This is just a variation of our slope formula. I could put a sub 2 and a sub 2 there, and that would mean the same thing. So this is derived from the definition of slope. Now, you can get away without specifically memorizing this. I'm not sure if I already said that, but I do think it's helpful, especially for further applications. And when you get into calculus and trig, we use some forms of things that look like this. So it's kind of helpful for you to already know it. And I find, after my years of experience, that having students use this formula generally ends up with less errors overall. So this is our point slope formula. Now that we have this formula, let's look at an example. In this example, we're asked to write the equation of the line with the given slope, m equals 2/3, which also passes through a given point, -6, -1/2. So what I'm going to do is I'm just going to plug everything into my point slope formula. Y minus -1/2 equals 2/3 times the quantity x minus -6. So all we have to do is plug my y and my x values in, and then my m value. Here we're going to distribute these negatives, so the double negatives will turn positive. We'll distribute that 2/3, and then we'll add this one term 1/2 over. So let's look at simplifying. I have y plus 1/2 equals 2/3 times the quantity x plus 6. Now I'll distribute that 2/3, y plus 1/2 equals 2/3 x, plus that would be 12/3 or 4. Y equals 2/3 x plus 4. That would be minus 1/2 when I use the additive property of equality to move that to the other side. And 4 minus 1/2, that's 8/2 minus 1/2. We've got positive 7/2. So this is the equation of the line. Now, this is not the only way you can do it. You could use y equals mx plus b, but that's kind of a two-step process. And one thing I have found over the years is that students will stop at b and not fully answer the question. So if we did it that way, y equals mx plus b, well, I have a y, -1/2. I have an m, 2/3. My x value is -6 plus b. So -1/2 equals -12/3 or -4 plus b. I'll add that 4 over. 4 minus 1/2 equals b, which gives us that b is 7/2. So I find that students will do that calculation and they'll stop right here. And that's not the equation of the line, that's just the y-intercept. So then we'd have to go back through and say y equals my given slope, 2/3 x plus 7/2. So either one of these methods is acceptable. I'm not going to say you can't do it a certain way, but definitely understanding this point slope setup will simplify some things for you and some formulas that you'll see in trig as well as in calculus. Let's work through one more example. In this example, we're going to do a multi-step problem. We're still asked to write the equation of the line, but instead of being given a point and a slope, we are looking at writing the equation of the line which passes through 2 points, and the points are given in function notation. So we are asked to write the equation of a line. And so what does that mean we need? Well, we need at least 1 point, we have 2, and we also need a slope. That was not given. So we're going to need to find the slope and then we'll use our point slope formula. So again, noting f of x equals y, that's our function notation definition, we have 2 points. We have the point 2, -3, and we have the point -6, 1. So my first step here will be to find the slope, because you must have the slope to write the equation of the line. So my slope, I have m equals, let's say 1 and -6. So that's my y is 1. 1 minus my other y is -3. And then I have -6 minus 2. That gives me a 4 in the numerator and a -8 in the denominator. The slope I have here is -1/2. Now that I know the slope, then I can go to my point slope form. So given a point and a slope, my point slope formula is y minus y sub 1 equals m times x minus x sub 1. And I can use either of my 2 points. Since my slope has a 1/2, I would just want to make sure that since I'll be distributing that either of the x's that I choose are divisible by 2, because I know I'm going to multiply that. But either point will give you the exact same answer. So setting this up, I'm going to use 2, -3. We have y minus -3 equals my slope that I just found, -1/2, x minus 2. So that's y plus 3 is -1/2 x plus -1/2 times -2 is +1. And I'll subtract my 3 value and I have y equals -1/2 x. 1 take away 3 is -2. And that's my final answer. So one thing I could do to check and make sure this was the correct line would be to make sure that both of these points work. So a check here would be to say 1 equals -1/2. I'll plug in -6 minus 2. That is 1 equals 3 minus 2, which is a true statement. that checks. You could also take this line and plug it into your graphing calculator's y equals, and then use the table to make sure that both of those points are points on the line. So there you have it. We did 2 examples of writing the equation of a line. This is a very essential skill, very basic algebra, and you're going to be using this for the remainder of your mathematical career. As always, if you have any questions, email me. I'm here to help. I'm your friend. Let me know. Good luck.